Welcome to this video on automated code review using managed agents. We'll analyze the autonomous performance of an SWE review agent as it processes a pull request, ensuring code quality and repository health. The system architecture relies on two key interfaces: the Agents API for configuration and environment management, and the Interactions API, which serves as the data plane for runtime communication with your agent. Here is a sample integration. This workflow shows how a pull request can trigger an automated pipeline, which then engages the managed agent's runtime within a GCP project, ensuring consistent validation. The agent operates within a secure, isolated sandbox, preloaded with a comprehensive set of Linux utilities, Python packages, and Node.js tools. It can also install additional dependencies at runtime if needed. This code snippet demonstrates how to define a custom agent configuration. It sets the agent's identity, system instructions, and provisions necessary sources, like GCS files, to be loaded into the workspace. Once configured, we use the Interactions API to invoke the agent. This script shows how to initialize the client and trigger an asynchronous, streaming request to review a specific pull request. In this specific pull request, the agent's shift from static analysis to dynamic validation proved crucial. It treated the new unit tests as executable code, uncovering latent defects that static analysis had missed. Stage 1 of the process involves setting up the environment. The agent clones the repository and checks out the specific branch, performing a deep analysis of configuration files to map project relationships. During initial validation, the agent detected over 20 errors. These were pre-existing issues in the codebase that hadn't been caught previously. The agent successfully halted the build to prevent merging broken code. The agent diagnosed the failures as missing ambient interfaces. It identified ghost types in the global scope that were causing critical TypeScript errors throughout the project. For its first fix, the agent autonomously restored the missing core types. By analyzing component usage, it generated and injected the necessary interfaces into the foundational declaration file. Next, the agent addressed dependency management issues. It discovered that the project lacked necessary type definitions for React, and autonomously added them to the developer dependencies to resolve remaining errors. Fixing the test suite was the third step. The agent enforced strict type safety in mocks by refactoring raw string literals into enums and correcting structural nesting issues to match the production interfaces. Finally, the agent resolved semantic drift in test mocks by fixing incorrect callback naming conventions. It ensured the mocks perfectly matched the production code, preventing hidden runtime failure points. With all fixes applied, the agent completed final verification. The build passed with an exit code of 0, proving that the architectural issues had been comprehensively resolved, and the code was ready for merge. Beyond simple error resolution, the agent provided architectural guidance. It identified that the use of path aliases and type definitions could compromise portability, recommending a shift to standard relative paths. This slide summarizes the findings from the pull request review. While the documentation in the new README was excellent, the test suite initially failed to compile due to significant type mismatches. These are the critical issues the agent uncovered. From missing base type definitions to incorrect object structures in the test suite, the agent provided a comprehensive breakdown of the necessary fixes. Here is the summary of the work performed. After cloning the repository and running type checks, the agent fixed the identified errors, exported missing types, and validated the build pipeline successfully. In summary, this process demonstrates the high impact of autonomous agents. By proactively remediating latent errors and enforcing architectural standards, these agents accelerate velocity while improving overall codebase quality.